Chapter 3, Lesson 4, using similar triangles. State Standard 8G5, where again, similar comes back to talk about all of our corresponding angles are congruent, and then it's also going to talk about as well that our sides in these two similar triangles are proportional. When we look at this, that's what we're going to use, and we're going to use this, the sides being proportional, to help us with indirect measurement. When we talk about indirect measurement, the definition is great. It uses similar figures to find a missing measure when it's difficult to find directly. So there is a word that, again, is kind of in the definition. But when we talk about indirect, it's measurement. Indirect measurement is something that we can't measure directly, meaning how tall is the school? How tall is the flagpole? How tall is that giant tree? Many times it's very difficult or impossible to measure with a tape measure how tall that building is or the tree is. So we can't measure it directly, but we can use indirect measurement where we'll be using similar figures to find missing measures. Again, before we get to that, a lot of the lesson deals on this, to just tell if the triangles are similar. Again, that means our corresponding angles need to be congruent. It'd be nice if they told us all three of them in each triangle. But what we're talking about, again, notice this triangle, they both have a 43-degree angle. So are we given these two the same? No. So then we're going to have to figure out either X or Y in one of them and hope it comes out to be something in the other triangle. We want all three sides, or excuse me, all three angles to be similar, meaning or congruent, that we have a 43 in both, 59 in both, and hopefully in this case a 58 in both. So let's find that out. I'm going to go with this one here on the left. You can pick either triangle you want, but I'm going to pick this. Remember, a triangle, all three angles add up to 180 degrees, so I'm going to do just that. I'm going to add them all up, and that is 58 plus 43 plus X. Out of habit doing that, of course, you could have just added those together right away. Tell me that that is 101 plus X equals 108. Solve that by minusing. Yep, I add a negative 101, which, careful with the mental math, careful with calculator and the signs that you do that. That gets us X equals 79. If X equals 79 degrees, do we have three angles that are congruent? We do not. So then you just say no. All corresponding angles are not congruent. And that's your explanation. All corresponding angles are not congruent. If you said yes, they are similar, then you would just say yes, all corresponding angles are congruent. Here we go again. Looking at the triangles, it would have been great if they gave us all three angles. They're going to give us a little extra work. It'd be great if we know two of them were the same. So we see a 52 and a 52. If the other angle that we're given, the 48 and the 80, if they were to match, then we know they're similar, because if two of the angles, or corresponding angles, are congruent, that means the third will be as well. So you need all three of them, but if we know two of them, then we can prove that they are similar. To do that, pick one. Again, for whatever reason, I'm picking the one on the left. Out of habit's sake, I'm going to show this step, so that way when we have multi-step problems, we can still do that. But of course, that can be combined right away to get you 100. So 100 plus X equals 180. And of course, you solve that by adding the opposite, adding a negative 100 to both sides, or of course, you could subtract that. Gives you 80 equals X. So if this X is 80 degrees, notice again, we have the 52 that we know is the same, and we know the 80 degrees is the same. So we know that these are similar triangles because two of the angles, corresponding angles, are congruent. Therefore, all three of them are. For the video notes purposes, I'm going to stop here. In class, I would go through and make a solve for y so we can see that it actually is true. If you'd like to, you can pause the video and solve for y and find out that y will also come out to be 48. So we do have all three angles that are corresponding, that are congruent. And that, again, if instructions say to explain, that's what you would just say. In this case, on this problem, you would just say, yes, all corresponding angles are congruent. One more example here on the right. I'm going to do the triangle on the right just to be different for us. Again, 180 degrees equals, add them on up. I've got 47 plus y, and that's only two angles, so don't forget this guy right here, the box, he means 90 degrees, so I'm going to do a plus 90. Once again, you could quickly do that. You can do mental math. You can use the calculator. Sometimes you might jump that step, and you would be allowed to right away, in my class, tell me 137 plus y equals that 180. Again, I do that because of habit's sake, so that way when we have a multi-step problem, we're still in the habit of writing down all of those and adding them all up with our like terms. Solving that, we did that because the x's get rid of each other. They cross-cancel. And you are left with mental math calculator approved, the answer of 43. So now go back and look. Do we have at least two? Notice again, we both have the 90, so we knew right away at least one was congruent. And now we've got this 43, which matches as well up there. So you've got the two 90s that are corresponding and congruent. You got a 43 that's congruent and corresponding, which again, if you did the math, you'd see that this one right here gives you 47 as well. So therefore, they would be all congruent corresponding. That's how you explain. Now, that's what most of your assignment was. And then we go on to finally indirect measurement, which I'm disappointed with the book and that they don't do more of this. So usually I have a day where we just do indirect measurement, whether around or on a worksheet somehow. But you can see down here, you plan to cross a river and you want to know how far it is to the other side. You take measurements and make the following drawing. Explain why triangle ABC and triangle DEC are similar, and what is the distance across the river. In class, I'd take a longer time to explain it, but this could be something that you might actually do in life, whether you're just doing it out camping or at the lake, or if it's maybe your job. I'd sometimes share about the Army National Guards or any type of military like that, where people's job is to build a bridge over a river, and they don't just walk across the river to measure how long it is. So they use indirect measurement. Step number 1, explain why these two triangles down here, triangle ABC and triangle DEC, which are not labeled in our notes, so I'll have to fix that for later, but why these two triangles down here are similar. Notice again, in order for them to be similar, definition says all corresponding angles are congruent. We only need to prove that two of them are congruent, in which case then we know that all three would be, and thus they are similar. Looking at it right away, you can see right here we have a 90 degrees and a 90 degrees, so that is one of our angles. And now I'd like to invite you to take a little closer look here. So let me get out my magic pen. In here on that river where we've got things going on, we zoom on in. Please note, we talked about this earlier, these angles here form a little X. So when we're looking at this angle inside this triangle and this angle here inside this triangle, when they are opposite each other in an X, we call those vertical angles. Back from lesson 1. More importantly, if I told you that this side was 30 degrees, this side would also be 30 degrees. Because these are vertical angles, we now know that they as well are congruent. So we know two angles are congruent. If you wanted to make a really good statement on this, you could say we have vertical angles, which are congruent, and right angles, which are congruent. Therefore, we have a similar figures because two or three corresponding angles are congruent. So I'm just going to write that in here. Not as much as what I just said, but we could just put down that corresponding angles are congruent. I'll put down 2 for notes purposes. But again, We could write that big old phrase, and that'd be great. Now that we know that they're congruent, that's the important thing. This only works if they are similar figures. If they are not, you're going to do wonderful math, and it is wrong. Now, just like we did with similar figures, now we're going to use a proportion to figure out the distance across the river. So note, again, when we talk about this, it is kind of important how we set things up. So when we're looking at this, I start with one of the shapes that I know. So so usually I do this. So the 50 over here is what I would write down first. So I've got 50, and that corresponds to which side over in this other triangle here. That corresponds to x equals, and then coming back over here, going to the 40 over to 30. We set up this proportion where corresponding sides are proportional. They form equivalent ratios. So again, there's a couple different ways to do that, but one way that always works is using the cross product, where you take and multiply those. 1500, you get 40x. Great. Again, to solve that, just solve that equation. So you're quickly going to divide both sides by 40. If it comes out nice, great. If it doesn't come out nice, you can use repeating decimal notation, or usually it should come out to be very nice. So this is 37.5 is what x equals. I've run out of room on the bottom of mine, so you have to forgive me. I can't slide this down there as nice as I'd like to. But here we go. I'll just bring it on down here for us so you can see it good. Now don't forget, that is 37.5. Need a label on that guy. You could put the apostrophe or just put the word feet. Now, that is an interesting drawing put in front of you. Usually what you'll see, a lot of them on a standardized test, love to talk about a light pole or a tree. So here I've got a tree casts a shadow of a 28-foot shadow, and a person who is 5 feet tall has an 8-foot shadow. Find the height of the tree, not drawn to scale. Now again, for me, I put these fun little pictures in so you can see it. If I had to, if it was just in front of us like in the word problem or something, you'd see me probably just, drawing a quick little tree for a visual, and then my little person, just something so I can see something. So you can always just draw out a quick little diagram, but for your notes, I've got the little tree here and the human. So when we're looking at this, notice it says find the height of the tree. It's not drawn to scale because the human and the tree aren't going to be proportional. So don't worry about that. What we're talking about here, we've got a shadow. So that is by a tree, casts a 28-foot shadow. And then the human has an 8-foot shadow, and he is 5 foot tall. So how do we find the height of the tree? Notice if we were to draw this in, do you kind of see the shape that we're looking at here? Notice how we've got two different triangles. So when we talk about it, you could draw these in and then, do the same thing I just did and then fill in your numbers and your numbers. Or you could literally just draw your triangle, draw another triangle and talk about, okay, here's a tree of some height and a person who's 5 foot tall with 8. Now you see the triangles. So whether you just draw the triangles in, you draw the people, if they give them to you, away we go. So again, we know they're similar because we're either told that, or again, because the sun's in the same spot, we know that this down here, this angle will be the same because of the sun's position. That's not always something we have to say, but if they ask how we know, that's how you know. Because this would be a right angle here in the corner. Now, let's solve. So I'm going to start over here. I know 8 corresponds to 28. So again, corresponds to this side. So then I'm going to come back over here and go back to the human where I have 5. And that corresponds to the thing I don't know over here, x, or in this case, I'm going to put an h for height. So again, maybe you see something, maybe you don't, but what we're going to do then is going to do that cross product. There we go. bing, bing, and get 140. And then going this way, getting 8h. Solve that by dividing by 8. And sometimes they come out to be decimals. Sometimes they come out to be whole numbers. But off to the side over here, I'm going to tell you that h equals 17.5 feet. Again, this phrase up here, not drawn to scale, you're going to see more of that as you go through geometry. What that just means is, technically, this tree over here is supposed to be 3 times the height of this human. That's not drawn correctly. So always go in geometry by with what you're told, not by what you see or how it looks. Today, understand the concept of similar triangles, identify similar triangles, and then use indirect measurement to find missing measures.